So good afternoon, everyone. I'm Emrah Kazan from Wayne State University. Uh, Thanks, Hani, for giving this opportunity to talk to you a little bit about building information modeling. As a trade, I'm a civil engineer. I've been in the construction industry for the last 15 plus years. And for the last 13 or 14 years, while getting my education in Wayne State, specialized in master's and PhD, I focus on construction engineering and management, mostly risk management, construction safety, and technology integration. And today I will discuss a little bit about what is our understanding from the researcher side, building information modeling, how we are equipping our students with this building information modeling concept or methodology so they can be future ready for employment in the industry. As a researcher, what we do is we investigate the problem areas in the construction. And as you know, in the construction industry, we have major problems, especially with the successful delivery of the construction projects. When we say success in construction, we can say that we are talking about the completing the project on time, within budget, and while meeting the client expectations. And we try to achieve this by using this triple constraint tools such as cost, scope, and time, where quality is attached to all of this. Our clients' expectations, compliance with what was defined in the scope of work, as defined in project specifications and in contracts. And they don't want disputes or claims, so they don't want any headache. However, construction is a very litigious industry, and they have to ensure that facilities or the final product perform for its purpose, intended purpose. So they want their projects must be delivered within cost, on time, and agreed upon scope, no more or no less. However, that's the challenge, because if you take a look at the bottom right corner image, you can be fast with cheap material, it will become inferior. However, you can be fast and good quality, however, it will be expensive. So there must be a sweet spot where you can land on your project, and that's the ultimate goal as a project managers. So if you take a look at the shortcomings, what's wrong with the construction right now, and why are we here, and why are we still discussing this building information model? For the hundreds of years since new computers are introduced to our industry, it has been two-dimensional, just papers, lines, and shapes. Analog drawings, schedules, and specs, they're all created in a paper-based system. And due to this, and there are too many dynamic environment in the construction site, and too many first-time collaboration between different companies, inconsistencies between the drawings or between documents, errors, omissions, and duplications, unfortunately, poor planning because of these errors and omissions, and construction industry, they don't like the prefabrication. They would like more on-site work. They produce on-site. However, due to these 2D analog documents, less prefabrication, and again, miscommunications between the stakeholders and lack of coordination lands us, as Laura and Austin mentioned and Haitham mentioned, a lot of RFIs, shortage of materials, claims and disputes, and unfortunately lack of quality and rework. So basically, we are end up such a bridge nothing meeting at end to end, and these lends itself as time delays and cost increase. That's what I always tell my students. In construction, at the end, everything is just a dollar sign, because time delays, rework, they just increase the cost. So therefore, owners does not like want to spend extra money, whatever they're budgeted on. This will bring us to BIM concept. It's been already mentioned and described. BIM, Building Information Modeling, is a digital representation of physical and functional characteristics of a facility from its life cycle, from inception onward to utilization until its demolition. So it is the main model that all the stakeholders, from owner to precast manufacturers, steel fabricators, engineers, detailers, architects, general contractors, subcontractors, they can all learn and understand what was the intent of the design, what the owner has in their mind, and what they want. So they can be all on the same page. It is just a concept. So BIM model is not just a three-dimensional model, or it's not just a 3D tool. The model itself knows what a wall is, a building element is, what it is made out of, what color it is, how big it is, where its location at. And these are all intelligent parameters. That's why we call them also it's intelligent model. And it is important to understand that through most have come to understand BIM as a 3D tool. It's also information-rich database. So it's a dynamic database attached to a 3D model that links and controls these model components. We can also call this as parametric modeling. There is a significant value in this three-dimensional aspects of BIM, but its ultimate value, it lies in the ability of aggregate, edit, sort, and compile this information through this model. This is a very famous graph that is created by McLeamy curve. So through the design phases, preliminary design to all the way to construction and operation, through the life cycle of a project, as we all know, cost of design changes goes up and ability to make impact cost and performance goes down. And in this traditional drafting workflow, in the traditional way, most of the effort is focused on the construction documentation phase. Usually in this workflow, this process yields the first design that meets the code, which is the most important thing for quality. Building codes are the guarantee for quality. And it's not necessarily the optimal design. However, with the BIM workflow, this effort goes towards the, earlier in the project, go to the detailed design, and where a designer have more room to make a change, and a project manager, construction manager can give more constructability input to these design elements, so they can come up with the best and most optimized design option, which an owner can select from. So this is how the BIM workflow impacts this cost and change and design optimization in the industry. Now, previous speakers already mentioned what are the benefits of BIM. I'm not going to repeat everything, but it gives us better design options, risk mitigation, increased productivity, and prefabrication. It's one of the major problems that we have in the industry: productivity and risk. So other misconceptions is, whenever say building information modeling, people say, hey, I know Revit, I can alter some models, so I know building information modeling. That's wrong, and that's what I tell my students. If you hear someone saying that I know Revit, so I am expert in building information modeling, to run away from them, because it is not just a software, it's a methodology. And it is the other misconception is it's just for designers and big projects. However, that's not the case. Everybody in a project is a stakeholder. They can benefit such a model. And as you see from this picture, there are different tools that serve for different purposes in the BIM methodology or BIM concept. They are all integrated and they're working together. That's why I believe one of the drawbacks of companies to approach BIM is the cost. When they see the software, the number of software, the hardware they need to purchase to adopt this concept scares them. However, in the long run, they return on investment is outweighs the expenses. So as a construction manager, how does construction managers benefit from this? They benefit mostly the information side and extend its use by giving it meaning for other related workflows, so such as constructability reviews, scheduling, estimating, and therefore they can optimize the schedule, budget, and overall quality. And big BIM workflow can work conjunction with the digital documentation. Right now, what we are at popular in the industry, digital documentation workflow. Through BIM models, digitized just-in-time field quality inspection can be performed. Mobile technologies, standardized quality programs with quality checklists can be integrated into BIM models with or construction management software, so they can be used. Issue tracking or RFA management. So we can say that quality control is no longer reactive, but it is proactive. And there are other benefits construction managers in the field can benefit from: manage in-field clash detection, clarify scope and work packages, perform 4D scheduling updates in their model, create a field sequencing clash detection, so they can optimize their site plan design and etc. Within this help of this BIM models. We said collaboration and coordination. We heard about this clash detection a lot. What does clash detection do during the pre-construction phase? There are different models, different authors, architects, structural engineers, MEP engineers. They design their system, even in the Revit, BIM authoring tools. However, they are not federated. When you become make this model federated, which means combined together, you may identify some abnormalities, inconsistencies, where you don't want to face them during the construction phase. So we call them clash detection. I will just initiate this one. So basically, most of the time the clash detections run for mechanical elements and structural elements. As you see in the example, even though this model was authored in Revit with following an author's footsteps, when we run this Navisworks exercise, we see that all the structural elements are conflicting with MEP elements. So in a case study where I read, such conflicts can drive the cost up to $1.2 million up, because if you face this right on the field, either you have to lower this ducting, that means that you need to lower your ceiling, that means that the owner is going to lose the clearance height, which they might not be happy. So all the reworks and etc. are going to cause extra cost to the owner. So you can identify these issues without even doing groundbreaking during the pre-construction phase. You can discuss this with the appropriate person and assign responsibilities, and until these resolve, you can get these problems taken care of before even doing the groundbreaking, as I said. So clash detection, it illustrates the project in a digital form, so it can be analyzed and determine the inconsistencies between the different disciplines, so the construction phase does not suffer from these problems. Oops. What about the 4D and 5D? So as you know, we attach time or schedule to our third dimensional models. So it is no different than just assigning tasks and start and end dates, plans and actuals, and attaching them to building components one by one, so to get the better understanding or sequencing of this schedule.
So for our project management professionals, the PMPs, understanding that BIM takes care of most of their knowledge management areas such as time, cost, risk, just using one software like BIM is doable.
Exactly. So that's what I was going to come to. Hi, thanks for bringing. So we say 40, 50, 60, 70, but I say you can add as many D's as possible because it is information and you can attach this human resource management, procurement management, sustainability analysis, structural analysis, user comfort analysis. Uh, all those things are possible with this digital formation of model. And with the advancing technology, now all the files or all components are compatible with each other. And this brings more use of with this just known three-dimensional model. Also, you can attach the cost, as you see on the screen, the total cost to this building with the percentage complete. You can see at a given time in the future how much it will cost and what to expect to see on screen or on the field. So by taking your iPad or your mobile device, you can see and compare how it is compared to your perception or assumptions. So you can verify them in terms of quality. And the 5D is attaching the cost to its fourth dimensional schedule. It is no different than cost loading as schedule. I'm sure everybody is aware of what cost loaded schedule is or resource loaded schedule. So uh, 5D BIM is again attaching cost to building elements, so you can accurately calculate, quantify, or do cost estimation within the model, quant takeoff, and there are other tools out there which you can benefit from the other dimensions. Now, where were we and where are we going with this building information modeling? If we say this building maturity, BIM maturity, right now, most of the industry is in the level 2 form. So level 0, as you know, it is chaotic. Nobody uses BIM. Everybody is analog, low collaboration. Everything is in 2D CAD format. Then level 1 is better than level 2. I mean level 0, because you involved in BIM, you are altering models, but it is just a 3D model. And level 2, most of the industry is utilizing is 4D and 5D BIM utilization. So full collaboration and coordination, and we are moving towards level 3. There are some companies out there that their maturity level is already at level 3. It becomes a fully integrated model, cloud-based. I believe Art will mention this, LiDARs, because don't get me wrong, building information modeling is not just for new buildings. For existing construction or existing buildings, you can also utilize this methodology by using point clouds, laser scanning, drones, or Internet of Things integration. You can benefit from this. And one other future improvement for this is predictive analysis, artificial intelligence. Now, by utilizing the lesson learned from the or digital information or digital documents, you can identify the risk factor for your subcontractors and whether or not they were going to create a problem at their job site. So basically, you can mitigate these risks so you can create a game plan. And robotics. I was not thinking that this would be possible. However, the dog robot that you see in the bottom is being utilized in the construction industry. They integrate this LiDAR machine, and by you getting the data from the 3D BIM model, they scan and they travel and they inspect the job site. So BIM is making possible for other technology integrations, and as also mentioned, VR technologies or mixed reality, such as HoloLenses or goggles, you can benefit from such a design validation or quality controls at the job site compared to your assumption, again, right on the spot and instantaneously get the feedback and assign issues to appropriate parties so they can be resolved without creating a big issue. So this being said, we said that information is power, and the BIM concept enables this power to successful project delivery. So hopefully construction industry is going to get into better shape in terms of technology adoption as well as successful project delivery. Thanks,
That
Sam.
was